By 1970, Boeing was one of the top commercial aerospace manufacturers. Its 747 jumbo jet had just entered service. American dominance over commercial aviation was complete. In the Western market, US manufacturers controlled the large majority of large commercial aircraft sales. Boeing, Lockheed, McDonnell Douglas. The game was over before anyone else could play. But here's what makes no sense. A European consortium with no track record as a unified manufacturer and no orders from American carriers decided to challenge this American monopoly. The partner companies had aerospace experience: Sud Aviation, Hawker Siddeley, Deutsche Airbus. But as a consortium building commercial jets, unproven. It didn't just build a competitor, it built an aircraft that would expose a fatal gap in Boeing's entire strategy. On the 18th of December, 1970, Airbus Industrie was formally created to develop the A300, the world's first twin-engine widebody jet. Early sales were dismal. Production fell to less than one aircraft every 2 months. Internal executives debated shutting down the program entirely. Yet, 50 years later, Airbus holds roughly half the global market. The United States monopoly lies in ruins. The 747, that was supposed to dominate the century, became unnecessary for most routes. And the idea Boeing dismissed as too small to matter, it became the blueprint for nearly every successful commercial aircraft since. To understand how audacious Airbus's gamble really was, you need to understand what they were up against. By the late 1960s, American manufacturers didn't just lead the Western commercial aviation market, they dominated it. Boeing, Lockheed, and McDonnell Douglas had spent decades perfecting the art of building large commercial aircraft. They'd accumulated engineering knowledge, supplier relationships, customer trust that seemed impossible to replicate. When Pan Am put the Boeing 747 into service in January 1970, it wasn't just introducing a new aircraft, it was announcing American supremacy in aviation for the foreseeable future. The 747 became an instant icon: massive capacity, intercontinental range, an unmistakable silhouette that redefined what air travel could be. Airlines around the world rushed to order the jumbo jet. At the time, bigger was definitely better for long-haul routes. Boeing's competitors responded with their own large aircraft: the Lockheed L-1011, the McDonnell Douglas DC-10. Both featured 3 engines to circumvent twin-engine diversion limits and provide redundancy over water. Europe, meanwhile, was a fragmented mess. Each country maintained its own national aircraft champion. Britain had its manufacturers, France had its own, Germany operated separately. Resources were split across competing programs that lacked the scale to challenge American dominance. Political squabbling consumed years of negotiations. Ministers demanded that their national industries receive specific portions of the work, regardless of capability, regardless of efficiency. Getting these nations to cooperate on anything seemed almost laughable. An aircraft program requiring billions in coordinated investment? Impossible. When Airbus finally came together, the early operator list told a revealing story. Air France, Lufthansa, airlines with obvious national state connections. Critics dismissed these as politically forced orders rather than genuine commercial validation. European governments were essentially buying from their own consortium to keep it alive. The regulatory environment made things even more difficult. In the 1970s, the FAA still had strict 60-minute diversion rules for twin-engine aircraft over water. Any aircraft with only 2 engines had to remain within 60 minutes of a suitable diversion airport at all times. The practical effect was devastating. Twin-engine jets were effectively barred from most lucrative transatlantic and trans-Pacific routes. The long-haul market belonged exclusively to 3-engine and 4-engine aircraft. American manufacturers held commanding leads in both categories. This created what appeared to be an insurmountable barrier. To compete in profitable long-haul markets, you needed large aircraft with 3 or 4 engines. Developing such aircraft required billions in investment, decades of institutional knowledge, established relationships with airlines worldwide. Europe had none of these advantages. The early attempts to organize a European response were marked by chaos. Airlines expressed skepticism about buying from a brand new consortium with no track record. Even after Airbus Industrie was formally created in December 1970, the organization remained a fragile political construction. The challenges facing this new consortium were almost comically severe. No production experience at scale, no established supply chain, no customer support infrastructure. Most critically, no credibility with the airlines that would actually buy its aircraft. Why would American Airlines or Delta trust their routes to an untested European experiment? Boeing offered proven reliability. The numbers told a brutal story. Between late 1975 and mid-1977, Airbus endured a devastating order drought for the A300. Almost no airlines committed to the program during this period. Completed aircraft sat on the tarmac with no buyers. Production rates dropped to roughly half an aircraft per month. Internal debates erupted over whether to simply pause production entirely, admit defeat. For Boeing, watching from Seattle, the A300 program must have seemed like confirmation. European aviation ambitions would remain permanently limited. The American fortress appeared impregnable. To understand why Airbus succeeded where everyone expected failure, we need to examine a gap in Boeing's strategy, a gap Boeing itself didn't recognize. Boeing's lineup in the early 1970s was built around a specific assumption: the future of aviation meant bigger aircraft flying longer routes. The 747 represented the pinnacle of this thinking: massive capacity for massive demand, 4 engines for maximum range and redundancy. But this assumption left a hole in its portfolio. Boeing lacked a purpose-built, twin-engine, twin-aisle jet, something optimized for around 250 seats and medium to long range. Its competitors offered tri-jets in this space, the DC-10 and L-1011, but these came with the cost penalties of operating 3 engines versus 2. The A300 targeted this gap with surgical precision. By using only 2 engines, Airbus could offer airlines lower fuel burn compared to American tri-jets on comparable routes. The aircraft's twin-aisle cabin enabled comfortable 242 seating configurations. Passengers preferred this to cramped narrow-body alternatives. Its wide-body cargo hold was efficient for the mixed passenger cargo economies that many routes required. Boeing recognized this market segment eventually, but its response, the 767, wouldn't enter service until 1982. That gave Airbus nearly a decade to establish itself in the mid-widebody twin category, with no direct competition. But here's where the story takes an unexpected turn. The A300 wasn't saved by European government support. It wasn't saved by clever engineering. It was saved by an American airline executive who had walked on the moon, and by a sales campaign so aggressive it bordered on desperation. Frank Borman had commanded Apollo 8, the first mission to orbit the moon. In 1975, he became CEO of Eastern Airlines and immediately faced a brutal problem. His fleet of aging narrowbodies couldn't handle the passenger volumes on high-density routes. But ordering 747s would be catastrophic overkill for Eastern's domestic network. He needed something in between. American manufacturers weren't offering it. Airbus saw an opportunity. They pursued it with extraordinary aggression. Demonstration tours across North America, A300s brought directly to airline executives who might never have considered a European aircraft. But they faced an immediate problem. American buyers were deeply skeptical of purchasing from a European consortium. National pride, concerns about support infrastructure, simple unfamiliarity, all created resistance. Airbus's response was clever. They deliberately de-emphasized the aircraft's European identity in US campaigning. Instead, they framed it as effectively American in industrial participation. The GE CF6 engines were American. Major component suppliers were American. By some measures, the A300 contained as much American content as European. Political and consumer resistance began to soften. The courtship worked. In 1977, Eastern agreed to lease 4 A300s for trial. After the aircraft proved themselves in service, Borman committed to a larger purchase, eventually 23 aircraft. For Airbus, this wasn't just an order, it was proof that it will survive. Eastern's adoption provided something that European government support never could: operational validation from a major American carrier. When Eastern's A300s performed reliably on high-density routes, the aircraft's economics became impossible to ignore. The fuel savings were real. The passenger experience in those wide twin-aisle cabins was noticeably superior to cramped narrow-body alternatives. What Airbus discovered, almost accidentally, was that the most profitable market wasn't the one it had originally targeted. The A300 had been designed as a medium to long-range widebody, but its most compelling economics appeared on medium-haul, high-density sectors, routes where narrow-bodies were capacity-limited, routes where 747s were absurdly oversized. Hub-and-spoke networks had reshaped airline operations, passenger flows concentrated through central airports. These concentrated flows needed aircraft bigger than narrow-bodies, but smaller than jumbos, exactly where the A300 sat. This discovery had profound implications. Airlines operating hub-and-spoke networks needed banks of departures, multiple flights leaving within short windows to connect passengers efficiently. The A300's capacity sweet spot, roughly 250 passengers, proved ideal for trunk spokes. A single 747 would be wasteful. Multiple narrow-body flights would be inefficient. The regulatory environment also began shifting in Airbus's favor. In 1977, the FAA began slowly relaxing ETOPS regulations, expanding the potential destinations the A300 could serve. The A300's success created something even more valuable than immediate profits. It established Airbus as a credible manufacturer. Operational experience, spares provisioning capabilities, customer references that could support future programs. Airlines that had never considered European aircraft began taking meetings. Boeing's response came. The 767 entered service with United Airlines in September 1982, 8 full years after the A300's commercial debut with Air France. During this gap, Airbus accumulated operator experience across multiple continents. It established support infrastructure. It built customer relationships that would prove durable for decades. Even more significantly, Airbus used the A300 platform to develop the A310, a shorter, longer-range derivative that entered commercial service in late 1983. This demonstrated something Boeing executives should have found alarming. Airbus had learned how to iterate effectively on its designs. Aircraft families that shared components, training requirements, operational philosophies. The concept of commonality would become one of Airbus's most powerful competitive advantages. Pilots could transition easily between different aircraft types within a family. Cross-crew qualification shortened transition training based on cockpit similarities. Boeing achieved unusual commonality between the 757 and 767, but Airbus formalized and marketed the concept as a familiar strategy. Fleet planners found it persuasive. The A300 also evolved significantly during its production run. The A300-600R variant introduced a two-crew glass cockpit derived from the A310. It eliminated the flight engineer position that had been standard on 1970s widebodies. This wasn't just a cost reduction, it signaled Airbus's commitment to cockpit and systems commonality, the foundation of their later fly-by-wire families. European government backing proved essential during the early years. This support gave Airbus the financial cushion to sustain painfully low production rates. Whether this constituted unfair subsidy or legitimate industrial policy remains debated. But the practical effect was clear. Airbus could afford to be patient in ways that a purely private venture could not. A300 production continued from the early 1970s until 2007, with final A300 cargo aircraft deliveries completing that year. An extraordinary lifespan for an aircraft that many had written off as a failure. While passenger service eventually became limited, the type found substantial second life value in cargo operations, the same pattern that would later define the MD-11's fate. Fast forward to today, Airbus holds roughly half the global commercial aircraft market. The duopoly that seemed unimaginable in 1970 is now the defining structure of the industry. Boeing's once impregnable fortress has been reduced to a constant street fight for market share. The 747, that was supposed to dominate the century, its production ended in 2023. Airlines discovered that smaller, more efficient twins could serve most routes more profitably. The jumbo jet's unique advantages persisted only for the highest demand trunk routes and for cargo, where its sheer volume remained unmatched. Even Boeing eventually built its own twin-engine widebodies, the 777, the 787, aircraft that competed directly with the philosophy Airbus pioneered. What Boeing dismissed as a European experiment became the template for modern commercial aviation. The twin-engine widebody that seemed too small to matter in 1970 became the ancestor of aircraft families that now dominate both manufacturers' portfolios. But market dominance is never permanent. The regulatory environment that favored 3-engine and 4-engine aircraft eventually shifted. Engine reliability improved, ETOPS expanded. The hub and spoke networks that made mid-sized widebodies essential were different when Boeing made its strategic bets. Airbus didn't steal Boeing's best idea, it stole the widebody concept and discovered a better application for it. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?